Number 7, the speed of Halley's Comet while traveling in its elliptical orbit around the Sun. All right, so here's our Sun. Here's our Sun. And we have to put an elliptical orbit. So, and that's our elliptical orbit. So what's happening, we can see that when we're in orbit, the velocity is equal to square root of big G, big M over little r. So we can see as Halley's Comet, as Halley's Comet starts approaching, when it gets closer to the Sun, the orbital diameter is decreasing slightly as compared to out here. So if, as it's approaching the Sun, its orbital diameter is going to decrease, that's going to cause its velocity to increase as near the Sun, and vice versa as it gets away from the Sun. You can also look at this from a gravitational point of view. It has much more GPE when it's at this position than when it's close to the Sun. All right? As it approaches the Sun, it's, if you will, losing some GPs, or that GP is rather transformed to kinetic energy. So kinetic energy has velocity as a component, so some of its gravitational potential energy is going to be converted to more kinetic energy, causing its velocity to increase as it gets closer to the Sun.